Have you ever taken a minute just to think about the actual value of your solar PV system? I'm not talking about a system that you've just recently had installed. I'm looking at systems that have been installed for a couple of years where the system has devaluated or the equipment have started degrading. We don't often think about the actual value of a solar PV system, but for financiers, insurers, or for corporates with large property portfolios, buying and selling an asset or a property that comes with a solar PV system has a lot of question marks attached to it because what is it actually worth? How far is it down the line from having to be replaced or maintained? Is the system working? And on a large building, what is the actual value of the solar PV system? It's quite a complex topic, and it's not something that if I do a Google search, I find answers on, or where I see that answers for the questions on the valuation of solar PV systems are readily available. So in this video, we are going to look at how to evaluate a used solar PV system and what to take into consideration when doing the valuation for a solar PV system. This, I think, is important for insurers, financiers, organizations with large property portfolios, or people that have solar PV systems and they want to get an understanding or an idea of what their system is actually worth and what it is they should be looking at when they try and determine the value of a used solar PV system. My name is Karel Ballack, and I have been presenting solar PV and engineering related training for more than 15 years. Join me in this video as we dig into evaluation of used solar PV systems. Let's jump right in. If we look at the image that we have on the slide at the moment, this is kind of where I would like to end. So this is what the slide is going to look like when we've finished this presentation and when we've finished this discussion. But in order to understand how to get here, we need to take one step back and just have a look at where this whole process starts. What we've got on the screen are three circles. We've got the green circle covering material cost. This is when you have a new solar PV system installed and the cost of the actual material, that would be the cost of the actual installation. That would be the entire green circle over here. The purple circle over here, we can actually move a little bit out of the discussion for now. We'll get back to this one. So with a new installation, you've got two circles. You've got the green one, which is the material. You've got the pink one, which is what the customer is paying. And then this overlap over here, that represents the labor portion or the labor component in a solar PV installation. The bigger your labor component, the smaller your material component. So these two circles would kind of interact with one another, and the material cost is still something that the customer has to pay for. He is not necessarily going to use the labor component to generate an income out of the solar system over the period, and that's why we see this overlap over here. So we've got a material component. This would be your solar panels, inverters, mounting structure, and batteries. And if you have any other part of the installation, if it's a ground mount system, it would be all the structural components that goes into that. Basically, everything that you have that is bolted down onto the building as part of the installation fits into the green circle. Pink circle, fairly straightforward, financial, but on the financial side, we've actually got two we've got two components to it. We've got what is being paid at the moment, and then we have what the kilowatt hours are worth. So what is being paid is what we are paying for the actual system, and what the kilowatt hours are worth is what we are going to be doing with the energy. In other words, are we having the system installed in order to generate an income, or are we having the system installed in order to reduce our cost for energy over the life of the system? We'll come back to this as we go through the presentation and through the slides. On the purple circle, we have two aspects. We have an emotional and we have strategic. So these are, I'd almost like to say, non-tangible value items to solar PV systems. Your emotional side of things would be for residential installations, and strategic would be for commercial installations. So as an example, in a residential installation, a homeowner would use the motivation, would use the emotional factor as part of the motivation for paying for the system, because you might be staying in an area where you don't have a lot of power security, you have regular bouts of load shedding, you could have periods where you don't have any power at all, maybe the grid is not very reliable, so you've got periods where you sit at home and you don't have any power. So the purple becomes the emotional value that the system has, or the emotional value tied to the motivation for buying the system to start off with. In commercial installations, you don't have an emotional aspect, you have a strategic aspect. You could have emotional aspects. The emotional aspect would be where you have two buildings opposite one another that are competing in the renewable energy space. So you've got the one CEO from the one building wanting to have a bigger solar system, or slightly more involved, more up to date technologically, because he's got the latest inverters, the latest equipment. That becomes emotional, but it kind of blends over to strategic, because the strategic component in the purple circle is something that corporates would use to motivate the sale of an installation that falls outside of the material and financial components. Here we look at things like being seen as a company promoting green energy, having to comply to green energy targets or green energy goals, might in one way or the other have a financial incentive, but it's a value that really sits outside of the material and the financial components. So for large corporates, the purple would represent strategic goals, and in a residential environment, purple would represent emotional. That's pretty much it. This purple circle can move around, and it can change size. The financial circle can move around, so the more expensive your labor component is, the bigger the overlap is going to be into the material side. So if we put it there, for example, you'll see that your material component becomes smaller as your labor component becomes bigger, but it still has an impact on the financial side, because someone has to pay for the installation. Okay, so that really covers three aspects that I think are the major components when we have to determine value for a solar PV system. Remember that we are still at the point where we've only just installed the system. Now, as time goes by, the system is being used. This particular slide you'll see at the top over there, it says residential solar PV installations. The only component that's different in residential and commercial is this emotional versus strategic. So over here we've got the strategic because it's linked to the commercial, and there we've got the residential slide, and that is linked to emotional value. In the overlapped sections, we now see other subcomponents creeping in that affect the value of the installation, and that you can't value a used solar PV system without identifying and attaching a value to each one of these subcomponents. So between the material and the emotional side lies operation and maintenance. Between the emotional and financial side lies degradation and aging, and between material and financial lies labor. Now, what I'd like to do is I'm going to skip over the residential section so we can get to the commercial side of things, because that's really what we want to have a look at, and this is really where the discussion lies. Because as easy and as straightforward as it is, there are lots of components to this discussion. Let's quickly jump into a commercial solar PV system. I want to start with the purple circle first. We said that the purple circle represents strategic values, and in the top left-hand text box, we can see a green image. In other words, organizations that has a strategic goal to have a green image. Organizations that have a strategic goal that are chasing a renewable mindset and maybe appealing to customers that are more focused on renewable or like-minded organizations. And then we see a strategic goal for appealing to the green economy. So the purple circle represents the value component that relates to all things non-material and indirectly or non-financial. You could, I suppose, throw carbon credits into the strategic part of things, because you, as an organization, you might want to claim carbon credits, but because it's something that has a financial tag to it or financial value to it, it would probably roll over into the financial circle or the financial component. If we go through to the financial side, which is the next side we quickly want to have a look at, we see item number one, bottom left-hand corner, we see tax incentives, we see depreciation, we see carbon credits, we see selling of energy, and we see saving of energy. So anything and everything that's financially related falls into the pink or the red component. Just above that box was a section that looked at degradation and aging. So as your solar system is being used, and as the solar panels become older, they degrade annually. That degradation is something that is defined in the warranty conditions for the solar PV panels. You should have a lifespan of at least 25 years out of your panels. There are some panels that have 30-year warranty or performance warranties. If you start looking at some of the older generation panels, you would find that the older generation panels at solar farms are now being replaced, not because they've come to the end of their life, but because solar technology has advanced so much that it's viable for them to take the old panel off and replace it with a different panel that is almost twice as efficient, delivering almost double the amount of power that the old panels delivered. So there are periods where it's viable to have an asset replaced without the asset getting to the end of its life or the end of its useful life. When we look at aging of infrastructure, this could relate to the aging of mounting structure, which shouldn't be a problem. Aging of conductors, which if the contractor has used the correct conductors, that shouldn't be a problem. Aging of panels we've covered. Aging of batteries would be covered by the battery warranty, and you need to go through the storage systems warranty conditions in order to understand what the requirements and limitations are on the aging of the battery. So you would want to access the data or the BMS, the battery management system. If it's a lithium ion battery, you would want to access or try and get access to the data from the BMS to understand how much of the useful life of the battery has been used and how much of it is left. When you look at aging infrastructure such as generator sets, you should be able to look at the generator itself, have a look at how well it's been maintained, and you should be able to find information on the number of hours that the particular generator set has been working. So most of the degradation and aging in electrical infrastructure should have data supporting the aging and how much of the useful life of that particular equipment is left, especially if you start looking at inverters, for example, which is an electronic component. If the inverters have been exposed to higher temperatures, the inverter might have a shorter life instead of a longer life. So if you buy a system that is 5 years old and your inverters only had a 5-year warranty, you've got to kind of look at that from a financial point of view and go, well, what is this worth as a energy generating or an energy saving asset? That is something that you have to look at, and it has to be considered. I would almost like to say every brand is going to have its own limitations and its own requirements as far as that is concerned. So you've got to pay attention to what you're doing there and how you are allocating those values. The next item we want to have a look at quickly is the material. If you look in the top right-hand corner, is only a block, green block that says original equipment. In other words, the system or the equipment that's been installed here, you want to go and have a look. You want to almost do a visual inspection of what the equipment looks like. What is there? Is there a bill of material? Is there a bill of quantity? Is there an asset register? In other words, do you have a list of the barcodes or serial numbers of the solar panels? Do you know which type of mounting structure has been used? Do you know which inverter has been used? Do you have a list of the inverter serial numbers? And over here, you could also have a look at the online portal. How do the equipment that's been installed, how does it relate to the online portal? How does it get the data there? Is it accessible? Is it transparent? Is it obvious to see what the condition of the equipment that has been installed on site is? This might also necessitate something like an IV curve test to make sure that the panels are actually working, logging into each inverter individually, ensuring that there aren't error codes, and that kind of thing. The last item that we can look at would be something like operations and maintenance. Operations and maintenance is a slightly overlooked item or component in used solar PV systems, because a couple of years ago, systems were still being sold as being free power. So once you've had the system installed, you can just leave it. It will continue operating well for the rest of its expected life. Solar PV systems have to be maintained. So you would want to make sure that there aren't any mechanical wear and tear on wiring and conductors. You'd want to make sure that you don't have issues with bimetallic corrosion. You want to make sure that someone has at least been around to wash the panels every now and again. There are quite a few things you can do to make sure that your operation and maintenance side of things are being kept up to date. Operation and maintenance, although it is a direct expense, is going to have a massive impact on the financial side of things, because if you keep your system operating and you keep your panels clean, you will more than likely find that the amount of energy that's going to be generated will be maximized over the life of the solar PV system. Now, what we didn't do in this video is we didn't physically take the time to go and look at the levelized cost of energy. We didn't physically take the time to go and look at what the impact of degradation on the solar panels and the impact of degradation on your battery systems, what that impact has and what the result is on the remaining life of the panel, and how that affects the financial allocation or financial cost of your asset. I think if you are going to get someone to assist you with this, because it's not a straightforward calculation. Maybe in one of the future videos we can do a calculation like this, but it could take a couple of hours, quite a bit of research, and quite a bit of work that needs to be done in order to understand the risks, in order to allocate the correct values, and in order to identify what the expected value or fair value of an asset is, if you want, if it's not new. Quite a few things you've got to take into consideration. It is or should be possible that if you have been watching this video, you should be able to find your way around if you understand solar PV systems, and you should be able to do this calculation. Should make for an interesting Excel spreadsheet, but there are quite a few things that you'd have to check. You're welcome to go through this video again, draw up a list, make sure that you've ticked all the boxes and that you've got all the values, and all you've taken all the different components into consideration in order to determine a fair value for your client. Guys, thank you very much. This brings us to the end of this video. I hope you've enjoyed it. If you have, like and subscribe, or just leave a comment, and we look forward to sharing some more great content with you in future. Cheers.